are both equal to what? 0. Okay. So from here, based on the direction of rotation, right? We also know that VD, yeah, I'm going to sketch out VD, is going to be just 90 degrees, right? And at this instant, at this moment, right? So VD will be equal to 18, and that length is what? The length is very early to do calculation like this. 0.2 plus by 0.3 multiplied by 18. Okay, so 0.2 plus by 0.3. So we are moving at positive 9 J meters per second. Okay. So we know that. Okay. Or you can use this to calculate VD. Another way to do it, which I'll show down here, you can use this equation over here, right? So we want to determine what is our VD. E, we know is equal to 0, right? In both I and J, plus this is going at 18, okay, anti-clockwise cross, and then the distance is equal to 0.5, so 0.5, and this is in I, okay? So if you use this technique, it will come out the same. So VD, K cross I is positive, so this is also equal to 9 J meters per second. Okay, so the answer, this is using scalar, okay, this is using vectors, okay, so the answer is the same. So now we know our VD is going in that direction. So the next thing that we will focus on is C and D. Okay, so the next one we're going to write VC. Okay, or before I go there, we are going to focus on member BCD. Okay, we're going to focus on member BCD. So if we focus on member BCD, we will write an expression that VC is equal to VB, sorry, is equal to VD. And then we have plus by omega. So we are looking at CD now, right? So omega CD cross, and then we have R C from point D. Okay. So what we are doing now, let me, so you see that as a diagram. Okay, so we are dealing with point C and point D. So we are dealing with that small gear over there. Okay. So at the center over here, this is our point D, right? You can see I'm drawing relative to the figure. So this is our point C. Okay. So from here, if you look at C, right, point C is connected to a bigger gear, okay, to a much bigger gear, right, or to the ring gear. Okay, I will shift this. Right, so this over here, they've just drawn. Ay. What I've just drawn down here. So over here, this is where our point C is. Okay. Can you all change the point C position? And this happened to engage our ring gear. Okay. So we were given that the ring gear is what? It's fixed. And when it's fixed, means what? The velocity is equal to what? 0. Okay. So in a planetary gear system, there's always one point that velocity is equal to what? 0. Are we clear? At that instance. So remember I asked you all earlier, in a planetary gear system, are all the gears rotating? And some of you say no. One gear is what? It's not rotating. And this is where we can assume velocity is equal to what? 0. Now this video over here, okay, I want you, I mean, we did that. They did show something really interesting. Okay, and now, how come there's no volume? Oh, this stupid thing does not accept volume. No, it does. Go on, okay. Hello? Wait. Hello?
Each other and show.
Oh, wait.
Planetary gear sets
Wait.
be able to predict same. Otherwise, they keep
Okay,
the same
watch this.
at their mating point.
VA is equal to VB.
The speed has to be the same. Otherwise, the gear teeth will penetrate each other as shown.
Can you see that?
An impossible condition.
Okay, remember I was walking around making a, where's that student? He's not here. Oh, he's there. Remember? He was spinning and I told you I was straight. Right? We are showing the exact same thing. Next time I won't call you. I will use this video. I do apologize, okay? But anyway, so we know if the where's my right? So when this is the case, right? We also know that VC is also equal to what? 0. Are we clear? Right? This is because of what? This boundary condition over here. And the velocity of the ring gear, okay, so velocity of VR must be equal to VC, and this has to be equal to what? 0. Why? Because the ring gear is what? It's fixed. Okay. So from here, we can declare that this is equal to 0. VD is equal to 9J plus, now omega CD, right? We are going to assume omega CD. Okay, did it give us a direction? No, I'm going to assume omega CD is going in a clockwise direction. Okay, so this is our omega CD, and I will put down here, we assume it to be going what? clockwise. Is it an assumption or not necessary? I'm just going to assume it for now. If it's wrong, we can flip the direction. Okay. So omega CD, right, is what we don't know, right? So we have our, we call it our negative omega CDK. And this will be cross, right? So where the point is, and given the geometry, oh, my eyes are failing me, is equal. So point C from point D, so it's going to be what? 0.1. Okay, so 0.1 I, right? Because can you see, like, this is equal to what? 100 micrometer. Okay. So from here, this will be equal to 0, 9J, K cross I is positive. Okay, so minus 0.1 omega CDJ. Okay. So we focus, there's only one component. So we put on based on J component. We have 0 is equal to 9 minus by 0.1 omega CD. Omega CD or 0.1 omega CD is equal to 9. Omega CD is equal to 90 radians per second. And because it being positive, right, the direction of rotation is in a clockwise. So you can cancel this. This is not assumed anymore. Okay, don't wipe out, just cancel it. Okay. Okay, so omega CD is in that direction. And because BCD is a rigid body, okay, we can now declare that omega CD is also equal to what? So what we're trying to find is the gear. What we're trying to find is the, hold on, what do we call this? Our omega B. Okay, is also equal to omega CD and is going at 90 radians per second and is going in a clockwise direction. So now we have completed our, so this is for our so we have our planet here. So it's not difficult, is it? Right? So the only thing that you have to remember is this boundary condition over here. Okay, anything that is fixed, the velocity is 0 and VC is equal to 0 because at this instant, point C is meshing the ring gear, the velocity has to be equal to what? 0. Okay, if the velocity changes, if velocity at C and the ring gear are at different velocity, you saw the animation, what's going on, yes or no? The gear will be damaged. Okay. So next thing that we're going to do, we are going to look at the sun gear. Okay, so we are now looking at the sun gear now. We are going to focus on the sun gear. Okay. So on the sun gear, we are going to okay. So this is our point E. And over here, This is our point A. Okay. Now, we know that the gear, so we have another gear down here. Which is in mesh. Right. And this is our point D. And over here, actually the gear is not so big, but this is our point D. We know that the gear rotate in this direction, and this is running at 90 radians per second, right? So, I mean, you can solve this any way you want, okay? But if we are going to use vector form, okay, and then we know what we're going to find is our omega AE, right? Now, in fact, now we can use your gear ratio that you have learned, right?